Hey grade 12s, it's me again with another part of calculus. As promised, today we are doing part 2, and for part 2 we are focusing on notation and rules, and I hope you have gotten a grip of the part 1 that we posted I think about a few days ago, that focused on differentiating using first principles. So today let us get to it. The first thing is our notation. I'm not going to be very long on notation, just to show you when they bring different type of questions and they ask you to derive, there's a certain notation that we follow, so you need to stick to it. The first one would be when they give you an equation or a function and they say f at x is equals to something, any value. F at x is equals to, let's say, 2x squared, for instance. If they want you to derive f at x, then the derivative of f at x, you write it as f prime x, meaning once you derive 2x squared, it now becomes, you say f prime x is equals to the derivative. You only write f prime x when next to it you are equating it to a derivative. That would be the first notation. And then the second one, we have dy dx. So dy dx means we are deriving y with respect to x. And now, when do you know when to use this? If they give you, let's say, an equation, they say y is equals to 2x plus 3. So 2x plus 3, when it's y being equated to x, then you are going to say the derivative of that is going to be dy over dx equals to, what you will write there would be the derived part of 2x squared plus 3. Okay, so you would see that the f at x and the dy dx, they mean the same thing. They mean the same thing. We just write them in different formats, but they all mean derive the function of y with respect to x. Okay, and then still on the dy dx, because we have normalized using y and x, on some questions you might have different letters. For example, if we have let me use s is equals to 2t squared plus 4. So now they are using different letters. We are using s and t, meaning still, if you have to derive that, you would say ds over dt, meaning we are going to derive s with respect to t. So what you're going to write there would be the derivative. So it would be the derivative of 2t squared plus 4, which I think also there should have just stated that is the derivative. So dy, so just be flexible with the letters. Just know that if it's s equals to t, then it's ds dt. If it's y equals to x, it's dy dx. So that is how we are most likely, no, that's how we are going to work it with dy dx. But all in all, it means the same. Dy dx and f at x, it means the same thing. We use the same format. And then the third one would be when we now bring in y prime. It is also working in the same, it falls within the same way in which we do rule number 2 and rule number 3. If you have y equals to 2x squared plus 3, and then your y prime, it's equals to the derivative. It equals to the derivative of 2x squared plus 3, meaning when you do y prime, what you write after the equal sign, it's the derivative of that. Okay, so that's what we mean. And then the fourth one is now d over dx, and then there we put a function. Let me just say f at x, because f at x can be any function. So d over dx, and then in a bracket we put f x. So you would see now from rule number 4, and also I'll do the same with rule number 5, they are going to be slightly different. So when you derive that, we're saying, okay, we want the derivative of the function with respect to x, provided that the function is that. Meaning you can have something like dx, and then we have 2x squared plus 3. So this is a question. This says derive with respect to x 2x squared plus 3. Meaning when you derive it, the equal sign is just gonna be what you have there is the derivative. What you have after the equal sign is the derivative of that. So with d over dx 2x squared plus 3, you just say equals to, then what you have there would be the derivative. It will work differently. If you think about, let's say we have dx, and then in the bracket you have x squared minus 1 over x minus 1, and they say derive. So I know we are still going to do the rules of deriving, the rules of derivatives. However, if you have a fraction, I'm just gonna sort of like jump forward now. If you have a fraction, we want to get rid of the fraction. So what you do is you still say, okay, d over dx, and then we can factorize x squared because it's the difference of two squares, x minus 1, x plus 1 over x minus 1. You see, I'm still carrying d over x. I'm still getting d over dx, and then I'm just now simplifying that fraction, getting rid of the fraction. The x minus 1 and the x minus 1 will go away. I'm left with dx, and then in a bracket I have x plus 1, which is going to be equals to just 1. Okay, so we now carry your d over dx up until the last step before you do the derivative. Meaning if you don't write that equal sign there, you can just say the final answer is just 1. Then you have it. So that's how you're going to derive with respect to d over dy of a function, which also will work the same way with dx. Dx also says, rule number 5, we are going to derive the certain function with respect to x. That function can be given there, d dx fx, which is also, we can give an example as d dx, and then we have 2x cubed plus 4x, and we want to derive. So this would mean that, okay, there we are deriving the function with respect to x. So you're going to write the final answer, and then that would be the derivative of 2x squared plus 4x. Okay, so that is all on your notation for deriving, guys. The next thing that we are looking at now is the rules for deriving. So on the rules for differentiating, we have about 4 to 5 of them, and the first rule is the one that says the derivative of a constant is 0. Okay, so remember, guys, what is a constant? A constant is just a number, meaning the derivative of any number that doesn't have any x on it, any variable, is going to be 0. So that is the first rule for being our constant. So the derivative of a constant equals to 0, meaning if we have y, it's equals to, let's say for example 9, then dy dx is going to be 0. So the derivative of y is going to be 0. That is the first rule. The second rule, it states that the derivative of x raised to the power of n, it's equals to n x to the power of n minus 1. Meaning when you derive x that has an exponent n, you drop the exponent and then you also subtract 1 from the exponent. Okay, the derivative of x raised to the power of n would be equals to n x to the power of n minus 1. For example, if we have y, it's equals to 4 to the power of, no, not 4, sorry, we have y, it's equals to x to the power of 4. Then it means your dy dx, you take the 4, you drop it, so you start with the 4, and then x, you subtract 1 from 4, which now becomes 4x to the power of 3. That is with the second rule. Another example, we can have d dx, and then you have negative 2x, not really negative 2x. Let's not get on to the third rule. You have negative x to the power of 4. This would be equals to negative 4x 4 minus 1, which is negative 4x to the power of 3. That is with the second rule, guys. And the third rule states that when you still derive x with an exponent n, provided that x has a coefficient, you still drop your n. However, you multiply the k with the n that you have dropped, and you still subtract 1 from the n, meaning it's gonna be k n x to the power of n minus 1. Okay, so if you are deriving x that has a coefficient k, you multiply k with the n that you have dropped there, you still subtract 1 from your n, and that is k times n x to the power of n minus 1. Okay, so that works for when your x has a coefficient. For example, if you have 4x to the power of 2, it's equals to let's say f at x, then f prime x, it's gonna be 4 times, you drop the 2, you still have the x, then you still subtract 1 from the 2, which is gonna be 4, sorry, we can't still write the 2, which is gonna be 4 times 2, which is 8, x 2 minus 1 is 1, so it's just 4, it's just 8x to the power of 1. Okay, you can also have a coefficient which is a fraction, so dx, your dx is x over 2, x squared over 2. So because you have x squared over 2, this can also be written as dx 1 over 2 x to the power of 2, which is going to be 1 over 2 is our coefficient times the 2 which we have dropped, x, then we still subtract the 1 from the 2, and 1 over 2 times 2 is just 1, x 2 minus 1 is 1, so your answer is just x. Okay, so this is when you have a fraction where still your x is a numerator, then you have a denominator that is a number. Okay, that can also work with when you have a negative number, provided that you have d over dx, then you have negative 2x to the power of negative 3. So this would be equals to, so we still keep the negative 2, we multiply it by, we drop the negative 3, so you have negative 3 x negative 3 negative 1, which now becomes negative 2 times negative 3, it's positive 6, x negative 3 negative 1, it's negative 4. So your answer is 6x to the power negative 4. If they say give your answer as a positive exponent, you can now remember, if you need to change your exponent from being negative to positive, if your x is a numerator, it just becomes a denominator, and then the 4 becomes positive, but only if they specify. If they don't, you can leave your answer as that. Okay, I hope you are still with me, guys. I hope you are taking note of the rules, because this you are going to apply when you answer that question 7, question 8 of your June examination under the calculus part. Okay, so that is when you have a coefficient in front of your x. Then now let us jump to the fourth rule. So the fourth rule says you cannot derive x when is a denominator. When your x is a denominator, you cannot derive it. You need to first make it a numerator. Then once it's a numerator, you can derive. Meaning if you have a to the power of x, no, meaning if you have a over x to the power of n, we can't derive that x. We need to move it to be a numerator. But remember, if it's jumping the fraction, the exponent changes. If it's positive, it becomes negative. If it's negative, it becomes positive. And then the derivative would be a times negative n x negative n negative 1, which is going to be a times negative n is negative a n x negative n negative 1. So that would be you moving your x from being a denominator to being a numerator. Another example over there, we have y equals to 4 over x squared. We cannot derive it yet. We can say, okay, that is equals to 4 times x, and then the exponent was positive, it now becomes negative. Then you can now say dy dx equals to 4 times the negative 2 that we are dropping there, x negative 2 negative 1, which now becomes 4 times negative 2 is negative 8, and then we have x negative 2 negative 1, it's negative 3. That would be your final answer. And remember, if they want it as positive exponent, you know what to do. You just take it to be a denominator. In this case, because it's a numerator. I hope you are still with me, guys. The second example is when you still have x as your denominator. However, x being on the denominator, it also has a coefficient. So you have 2 over 3x to the power negative 2. They want us to find the derivative of 2 over 3x to the power negative 2. We want to move the x to become a numerator because we can't derive it when it's a denominator. Meaning, when you move the x, most importantly, you do not move it with the coefficient 3. The 3 must remain, so you have 2 over 3. The 3 stays as it is because we are not going to derive the 3, we are deriving x. However, your x will now be x positive 2, and then now you can derive. You say now it's equals to 2 over 3 times the positive 2, and then you have x, we subtract 1 from the 2, then our final answer 2 over 3 times 2, that's 4/3. X 2 minus 1 is just 1. That is now your final answer. So guys, if your x has a coefficient on the denominator side, just normalize moving just x. That is the 4th rule. Now jumping on the 5th rule. The 5th rule says the derivative of a sum is the sum of the derivative. Okay, the derivative of a sum equals to the sum of the derivative. What does this mean? What does it mean? The derivative of a sum equals to the sum of the derivative. This means if you are deriving a sum or an expression, for example, they give you f at x, it's equals to 5x squared plus 3 over x plus 2. This is an expression, it has 3 terms and we have to derive it. You are just going to derive each term separately, meaning before we can derive, we see our x there, we see ux, you are now a denominator, and we don't want denominators. We don't want you to be a denominator, meaning you have to jump the fraction and become a numerator. Since you had an invisible 1 there, that invisible 1 now is going to be a visible negative 1 times 2. And then at this point, because what I'm going to do now, I'm going to derive. Now I can say f prime x. Remember, the moment you say f prime x, it means what you write after there is the derivative. I didn't do f prime x there because I was still sorting out my x there. The guy was now a denominator, and the guy must move up and become a numerator. But now that I'm deriving, then we'll say 5 times 2, that 2 there that I'm dropping, x 2 minus 1, and then plus 3 times, I'm dropping the -1 there. I'm just going to put it in a bracket just to avoid this thing looking complicated. -1 x minus 1 minus 1. The derivative of a constant, it's a 0. I'm going to write that as a 0. Then my final answer, f prime x, is 5 times 2 is 10. x2 minus 1 is just 1, which I don't write. And then that side, I have positive 3 times -1, which is -3. X minus 1 minus 1, it's minus 2. And that is going to be my final answer. If they say write your answer as a positive exponent, you know, guys, f prime x is going to be 10x minus 3 over x squared. Simple. If you are making it a numerator or a denominator, you just change the sign of your exponent. If it's positive, it becomes negative. If it's negative, it becomes a positive. Now jumping onto another example. For this example, we have d over dx. In a bracket, we have 1 over 4 x cubed minus 1 over x minus a pi. Wow, what is a pi doing there? So now we have a fraction, and already we are looking at that over there. We don't want that guy to be below the 1, to be a denominator. So because I haven't started deriving, I still keep this as it is. I'm saying, okay, 1 over 4 x cubed minus 1 times x minus 1 minus a pi. Now I'm starting to derive. I'm getting rid of that. I'm saying that is equals to 1 over 4 times 3 x3 minus 1 minus 1 times minus 1 x minus 1 minus 1. The derivative of a pi, guys, a pi, remember, it's a constant. If you press pi on your shift pi on your calculator, you get 3.14 and other numbers. So that is a 0. So that is negative a 0. And the final answer would be 1 over 4 times 3. That's 3/4. And then x3 minus 1, that's a 2. -1 times -1, it's a positive 1. And then x minus 1 minus 1, it's minus 2. And then that's a 0. So it means our final answer is 3/4 x to the power of 2 plus x, meaning our answer is 3/4 x to the power of 2 plus x to the power of -2. Okay, and then let us explore more on another example where we still have a fraction. So on this example, we have x cubed minus 3 over x squared. So our x doesn't have any coefficient, meaning okay, let's say this is y equals to that, meaning the first thing that I'm going to do, I'm going to get rid of that x from the denominator. So I have x cubed minus 3. The moment I bring the x up, please see, guys, I introduce a bracket there to say I'm going to distribute the x inside of the bracket, meaning now I have x to the power of 3 times x to the power of -2. Then we are multiplying the same exponent, so we are multiplying the same basis, so we add the exponent. So that's x to the power of 3 plus -2, which is 1. And then we have -3 times x to the power -2, that's -3x to the power -2. Now I can say dy dx, it's equals to the derivative of x, because it's going to be, I have a 1 there, I drop the 1, and then I say x1 minus 1 minus 3 times minus 2x minus 2 minus 1, and my dy dx is x to the power of 1 minus 1, which is 0, and anything to the power of 0, x to the power of 0 is 1. Anything to the power of 0 is 1. It means I have 1 times 1, which is just 1. -3 times -2, that's a positive 6, x to the power of -3. Okay, so that is deriving a fraction. And then you can also have multiplication of two binomials. So if you are multiplying two binomials, example, we have d of x, and then inside the bracket you have x plus 1 and x minus 4. So you cannot derive when you have a bracket. You need to get rid of the bracket. Since you have not started deriving, you still keep everything inside the bracket. X times x, that's x squared minus 4x plus x minus 4, and then your dx now becomes x squared minus 3x minus 4. Now because I'm deriving, it's gonna be equals to 2x minus 3. That is the final answer. Okay, and then from there we now jump onto our last rule. Our last rule says you cannot derive a set. So when you have a set, you need to remove it. You cannot derive anything that is under a square root or a cube root. And if we do a little bit of revision, remember guys, if you have x, square root of x, when you remove the square root of x, you don't square it. No, that is only applicable on equations. When you have x squared, square root of x is equals to something, then you can remove that square root by squaring both sides. But if it's just square root of x, it can be written as x to the power of 1 over 2, provided that, remember, a square root has a 2 there, the x has a 1 there. 1 over square root of x plus square root of 2 over, let's just keep it as square root of 2 over x plus the cube root of x squared. So that is your y, and then they want us to derive. So firstly we need to get rid of those. So the 1 over square root of x is going to be x to the power of a half, plus square root of 2 is going to be 2 to the power of a half, and then your x stays as it is, and then square root of x squared is going to be x to the power of a 2/3. And then now we still need, because with x, our x is a denominator, we still need to get rid of it. So you're going to have x to the power of negative 1 over 2 plus 2 1 over 2 and x to the power negative 1 plus x 2/3. And now we can start deriving. Dy dx, it's equals to, I'm going to drop the negative a half x negative a half minus 1, and then I'm going to multiply 2 over a half, 2 to the power of a half with a negative 1, 2 to the power of a half, 2, okay, I'm keeping the positive there, 2 to the power of a half times negative 1 x negative 1 negative 1, plus I'm going to drop the 2/3 x to the power of 2/3 minus 1. And then the next thing that I have is negative a half x negative a half negative a 1, it's negative 3 over 2, and then 2 to the power of a half times negative a 1, it's going to be a negative a 2 to the power of a half, x minus 1 it's minus 2, and then plus 2/3 x 2/3 minus 1, 2/3 minus 1, that gives us 1/3, negative 1/3. That is your dy dx. Okay, I hope you have gotten a grasp of this, guys.